What is up guys, and welcome back to this channel. Today is a super exciting video because today we're gonna start a new series that will go through the complete steps from napping as parts like this into a fully functional quad and getting it up in the air and actually flying. So what we're building today is gonna be a quad that supports 6S power and with 6-inch props that will be great for like a bit of a longer range flights and do this like cinematic flying. You've probably seen the videos, they are everywhere, of FPV drones competing with the DJI Phantoms to get the most cinematic shots. So in this video we'll build a quad that is nimble and fast, so you can definitely use it for freestyle, but that's specifically more made to get this like cinematic footage and to fly a bit longer. We'll also install a GPS in this craft, which is pretty cool. I'll go through all of the components as I go and actually use them in this video. So if you want a more detailed list of all the components, you can check out the description below for some more information. So this is the first part, and here I will of course build the whole thing. I won't do any like software setup or anything like that. So this video is only the build process. So the first step in building a quad is of course taking a look at your frame. So I went with this slossy style frame, it's called. It's just a cheap frame that supports 6-inch props. Now when you do select your frame, I would recommend getting something cheap in the beginning. Try it out, like see what you like so you know what to look for, and then maybe go for something like a branded frame with some other bigger name behind it. Because with your like first build, you're not gonna really know what you're after, and once you do like crash that frame and break it, then you probably know what you want to go for. You can see my frame is really nicely painted, and that is because I hydro dipped this frame before putting it together. And if you want to do hydro dip your quad, I would definitely recommend doing it at this point, like before you start the build, because it's just super easy to hydro dip it then because the frame is already in pieces and it's not actually all that difficult. So if you want to do that, you should definitely check out my other video on hydro dipping. I'm actually gonna assemble the whole frame now because I want to get a feel for how I will lay out the components later. So yeah, it does seem to fit. It all comes together quite nicely, and this is what the frame will look like once it's finished. So for the stack, I decided to go with this Mamba stack. It's a really nice and affordable stack, perfect for a build like this. So in the stack there is a F4 flight controller and also a 4-in-1 ESC here in the bottom, which has an output of 40 amps, which is pretty insane. It's a huge amount, especially for a 6S setup. And this of course supports up to 6S. And we see that we have a bit of space here on the top. So then we're gonna need to fit the receiver and also the VTX. So this receiver that I went with, that works with my Turn Evolution, actually has these like standoff mounts, which is really nice. So it is very easy to mount it inside your stack. However, I don't really know if there's going to be enough space, because the VTX can also be mounted in the stack. So here we have the VTX. So it's going to be very tight to fit all of these things in the same stack. So I think I'm going to actually mount like the receiver here in the back instead, and then probably the VTX like here in the top section of the stack. Might as well like lay out all of your components. So I went with the Caddx Ratel as the camera. I've heard a ton of good stuff about this camera, and also I really love the Caddx camera on the Gepard C Phantom. So I bet this one's gonna be really good. So then we'll have the camera over here. Yeah, so that is pretty much what it will look like. So with this frame you do get like plenty of space. There's a lot of like free space here in the middle, which is really nice because then you can always like add stuff later. And of course, as I said earlier, we're also gonna be adding a GPS. So here I have the GPS, and I think I will place this unit like in the back, but the GPS isn't really so important. I will focus on the other stuff, I think. And there is plenty of space, so it will fit everything. I think I will just make like a 3D printed mount here actually from the standoffs to hold this in place here. So I'm pretty satisfied with that layout. So yeah, I guess we'll start building then. Okay, so one thing that's very good to do when you get one of these new flight controllers is actually plugging in before you connect anything, because that way you know that it's working like when you got it. So this one lights up. We're gonna open Betaflight on the computer. And as you can see, it does connect, and we can see that it orients according to the quad here on the Betaflight setup. So I'm gonna start by attaching the flight controller and most importantly the ESC, because I'm gonna start wiring the ESC, like start from the bottom. And there's an arrow on the flight controller right here. It says which way the flight controller should be oriented. You can always change that like in Betaflight software, so you don't really have to think about that. But in this case, it's most convenient to have the arrow that way, because then I have easy access to the USB port, and also my battery lead comes out here in the back, which is nice because I'm gonna wanna have like the connector here in the back. Also, another pro with that is that the camera connections are right here in this cluster here, which means that when I put the camera here, there will be very short cables to the camera. So it's definitely intended to be this way. Perfect. And this flight controller actually comes soft mounted, which is pretty nice. One complaint, however, is that it has these pretty huge standoffs here in the bottom, so I might actually want to change those out for these bolts instead. You're gonna get more of these screws as you start building more quads, and then it's gonna be easier. But yeah, like there's always gonna be, it's really hard to like plan which standoffs you're gonna need and stuff like that. Let's put on the spacers like this, because this is the front here with like this big cutout. The camera. There is enough clearance here in the bottom, and there really is. There is just a lot of clearance, so yeah, that worked perfectly. So since we're starting in the bottom, we actually want to attach the motors right now, because we want to fix all of the connections to the ESCs down here in the bottom. So we might as well just start attaching the motors to the arms. So here are the motors. I went with the Emax Eco motors. They are 700 kV and a 2306 motor. So this is a great like budget option if you want a motor that supports 6 cell batteries and still has a pretty fair performance. So this is what they look like. They have a naked bottom like this, and they actually feel pretty heavy. I'm surprised over how heavy they feel. But they definitely seem to be pretty high quality motors just looking at them right now. They do have a lot of windings, and they also have like this hollow shaft to save some weight here, which is cool. So we're gonna attach these motors to the arms now. So here you have 2 different lengths of screw, and also of course the prop nut. So you definitely don't want to use a too long of a screw, because what happens then is it might touch the windings, and then your motor might either burn up or simply don't work at all, which is super annoying. So yeah, always make sure that you have the correct length, so they don't go like through this and start touching the windings. So now I got the last motor attached, it's time to work on the arms. So as I said earlier, I'm gonna use these LEDs for the arms. So it doesn't seem to matter which way you connect it up. I'm guessing it doesn't, because there is like alternating current to the motors. Now you should get one of these for your first build. It's a really good tip, because these will really help your quad survive like splashes of water and stuff like that. The last thing you want to do is like having your whole quad burn up just because of like one drip of water. So this is really nice. I'm gonna actually just detach the flight controller right now, and we're gonna spray the bottom of the ESC. Then I will connect everything on the top of the ESC, and then we'll actually spray the top of the ESC as well. So one thing to keep in mind when you do use this spray is it might actually like clog up the connectors and stuff like that. So you always want to have like all of the wires plugged in while you spray this on. Also, it can also make it harder to solder on these pads. So that's why I'm only gonna spray the underside, and then I'm gonna solder everything on the top side. And once I'm done with that, I'm gonna spray the top side. and then we'll just go ahead and continue up. So now that I got that coat on, we can see that it has like this very reflective surface because it's covered in this like plastic gel. Now this will harden if you give it some time, and then it will be like a protective layer over everything. So this is just hands down a super good tip. You definitely want to do this. It doesn't really take much time, and you're gonna be thankful for yourself for doing this later. I won't actually solder anything on the bottom part of the flight controller as well. So yeah, I'm just gonna go ahead and go out and spray that bottom side as well. So I actually conformal coated the back side of these ones as well, just to be sure that there isn't any like conduction with the arms. So we're gonna go ahead and solder the motor connections. So for this I will use a fairly large tip for my soldering iron, and I'll just go ahead and connect them to like the most convenient and neat looking path as possible, because the order we put in the cables will only change the direction of the motor, and we can always change that later in BLHeli software. We also got this capacitor with the ESCs and stuff, which is nice, so we're gonna make sure to attach that one as well. So here we can see the connections. We have motor 1 right here, motor 3 right there, 4 right there, and 2 right there. And then we just connect the battery leads in the bottom like this. So it's super simple. You can it's always good to like verify with the wiring diagrams for your products. Here we can also see a very simple wiring diagram for all the different things we can connect to the flight controller. So I'll just go ahead and pre-tin all of these pads right now. You really want to touch like the whole pad so it does like float out over the whole surface. If this is like your first time soldering, then you should definitely just be careful, do one at a time. Be careful not to heat it too long. If you feel like it's not working for you, then you can always just remove it, wait for it to cool down a bit, and then try again. Then we're gonna start attaching these wires right here. And these wires are already pre-tinned, so yeah, I don't need any more tin right now. And then just let them cool down for a few seconds, and then just make sure that they sit firmly. So yeah, it's always good to like drag a bit to like gently them to see that they just sit. Once you've done that, we can go ahead and route these wires through here. So now you can see we have some extra wires. Now this, we could have actually used this for the wires right here. Once they're all stripped, we're gonna just pre-tin them. We got them all connected like that. Looks beautiful. Now we're just gonna cut these cables to perfect length. There we go. That's the first motor done. Then we'll just go ahead and do this process with all of the motors. And of course, if you don't want to use one of these LEDs, you could always just wire this directly through. So this looks great, but about now I'm realizing that this is actually the wrong way. It should be like that, because here's the front and here are the battery leads. And we definitely want like the battery leads going out the back. So yeah, I'm just gonna remove these connections right here and we're gonna flip it. So now it's actually the right way around. So we got the first one done, and as you can see, the wires here are actually covering a lot of the circuit board. So I decided to actually cover this whole thing in this plastic spray before I soldered the wires on, just to make sure that all of these components here on the circuit board are actually 100% covered. So the thing is with this one, you can actually solder after you had applied. It's just a bit more difficult. But once you do start to solder, this kind of evaporates. So I'm gonna actually spray it right now, and then I will spray it also once I'm done with all of the connections, so all of these solder joints also are covered in this plastic spray. So we got it covered, and hopefully it should survive, like if you want to fly through fog and crash in wet grass. So then we'll just continue on and wire up all the rest of the motors. So we got all of the ESC wires sorted out. So I'll just take some super glue and put it on the underside of the LED strips. So it does seem to sit pretty well over there. So then we're gonna go ahead and attach the next one. Now, if you had like some bigger like translucid heat shrink, you could definitely put it over like the whole arm. That would be quite neat, but I'm not gonna do that now. but we'll see if I get some of that in the future. So it's looking good. We got like the base of the quad assembled. This is always the first step, getting like your ESCs, the power distribution board, and the motors sorted out. There is one connection, however, that I haven't soldered on the ESCs, and that are of course the XD60 connector. Now I got these wires with it that were actually really short, so I haven't really decided how I want it. Like, I think I'm gonna put it like here on the side, but I'm not sure. Maybe I want to put it here in the back. If we were to have this right here, there would just be plenty of space. But you know what? I think I'm gonna use this cable because it has a really nice silicone. But yeah, I would definitely wish that they had included a bit longer of a lead, because that's really short. So right now I'm just taking this really large like iron tip, putting it on here like so, because these really large tips, they have like a lot of mass, so they will store a lot more heat. So that's why they're good for these like big plugs. Also, we're gonna make sure to like pre-tin the wire as much as possible, of course. And if you're doing like this yourself, I would recommend like getting someone to help you, because if you can like tin it while you're like trying to attach it, that's gonna be a lot easier. There we go. It's always good to, especially when you do these bigger solder joints, like make sure you really inspect them and see so that they look good and then there aren't any like bridges and stuff. But these look pretty solid, so we're gonna stick with that. Then we'll just go ahead and add the standoffs, and then we can continue adding our flight controller and start wiring that up. So now we're actually finished with the bottom part of the frame. We're starting to make some progress here. One thing that I realized, however, is that if you look at the pinout for this flight controller, it only has 3 UARTs, and we'll need to connect the smart audio for the VTX. Then we'll want to use, of course, a digital protocol with the receiver, and we also want to use the GPS, which means we really need to utilize all of these 3 outputs. So the problem is, if you look at the pinout here, there isn't actually like a pinouts for the UART1. The only thing we have is the S-bus output, which is connected to the first UART. So if we want to use all of these 3 connected, we actually have to use S-bus on this receiver. We can't use I-bus because, well, there simply isn't a RX1 input. Now, there might be some other way to connect it, I don't know, but from looking at this diagram right here, there really isn't a RX1. And the S-bus is not inverted, which you need if you want to use the I-bus signal. So we're going to connect this guy using S-bus instead. And I'm going to place the receiver around here somewhere. I'm going to make like a super simple 3D printed mount here to mount it, screw it tight. Then the GPS will be placed like back here, sticking out of the back, so we can get like a clear reception. And then we will add this VTX on top here, connecting that like that, and of course the camera in front. So we're gonna start by connecting the camera, I think, because the camera is kind of the simplest thing to connect. So yeah, it will be very easy. Here I do got like some teeny spacers. So here I got some small screws as well. We'll just go ahead and try these. So we have a camera in the front. Pretty cool. It's a very tiny camera for such a big quad, but definitely works. And I've heard a ton of good stuff about this camera, so I guess it's gonna be like, my hope is that it actually is like really good. So we can see here the input voltage, it says 5 to 40 volts, so that's pretty insane. So we can essentially connect it wherever we want. But I think I'm gonna use this like 9 volt output right here, because that's very convenient. It sits like perfectly where I want to connect it. So yeah, we'll just use that one, and then we'll of course connect it to the cam right here. We could of course use the 5 volts as well, but I think we're gonna save the 5 volts because we will probably need it for other stuff anyways. And if it does support high voltage, then high voltage is always good, because high voltage means less current, and that means less power loss. And here you can also connect the buzzer. I will definitely do that. So I'm gonna pre-tin the buzzer pins and then also all the camera connections. There we go. Then we can just go ahead and use our tweezers and start connecting the wires. So the reason you want to connect the camera to the flight controller is so you can use the OSD. So you put the camera feed into the board and then it adds all the on-screen display information and then it outputs that to the transmitter. So you can connect one of these beepers up. You could also use, like most ECs supports beeping with the ECs these days, so that's really convenient. But on a large craft like this, it could definitely like handle the extra weight and stuff. So yeah, you might as well just add a beeper like this. So there we go, the beeper is firmly attached there. You definitely want to make sure you have some kind of way to beep with your quad, either with the motors or the beeper, because you really don't want to lose your build. So definitely invest in one of these beepers. They're really cheap and there's a super simple way to save your quad. Then we'll just go ahead and connect our receiver. I'll go ahead and connect that one to the S-bus and 5 volts and ground here. So there it actually says LED. That is interesting. I wonder if that's an RX one. Then we'll just double check that we connected everything correctly, which we did. So you always want to like double check this, because if you do it wrong, get the polarity wrong or anything, you might break stuff, and that's always really annoying. So now it's time to connect the VTX, and it does have a few cables. So here we have 3 leads, and then here we have 3 other. So this one is actually made with a connector, so you can plug this one right into a camera if you wanted to, and then you could just power this VTX and have smart audio over here. But since we want to use the OSD on the flight controller, we're not gonna use this 5 volt output right here, so these 2 wires are unnecessary for us. So we'll just connect the yellow wire to the video out from our flight controller. It needs at least 7 volts for the plus, so we'll connect that to the 9 volts. And we will not connect it directly to the battery, even though it can actually do that, because when we do connect it to the 9 volts, then we have some cleaning of the power feed from the flight controller, which is great. And then we'll use this white wire to connect that up to our TX so we can control this unit. So if you look at the wire output, once again, we have everything here neatly organized. We have ground, then we have TX3, and then we have the video out. So we'll use just these 3 cables right here. Then we'll just go ahead and cut the 2 voltage regulated wires we don't need. We'll just cut them pretty short like this. So if in the future you want to reuse them, you actually can. Then we'll go ahead and cut the yellow wire just enough so we have this spare connector. We don't need that one. So we will attach this one like this, which means our wires won't need to be long at all, but we're probably making like this long. So I'm just gonna cut all the wires over here. We'll just start connecting these up. So we'll start with the video cable. Then we have the TX3. We'll connect that one to the RX port. Like that. Then we have the ground, so we'll just connect the back cable. And then we have the 9 volts in. So we'll go ahead and connect that as well. It does look a bit odd though, with these 2 just hanging out. I wish they had made like soldering pads on this one. It would have been much nicer. I do prefer that. So finally we have this GPS. It needs a 5 volt input here in the red wire. The black wire is of course ground. Okay, so the TX is the one closest to ground. So yeah, the white one is a TX and the green one is the RX. I'm thinking about connecting it, like having it sit like here somewhere around there. So I'm gonna cut my wires about this long. So we're gonna have to connect this one here to the ground, the 5 volts, and then we'll go ahead and use the TX and RX6. That's the one we haven't used. We just use the TX3 to the smart audio to this little guy. Then we have the 5 volts, so we'll just go ahead and connect that. Then we have the TX6, so we need to connect the TX. So we have the TX6 and we need to connect the TX to the RX. So the RX is the one that's next to the VCC, which means we have to connect the green one. There we go. So at this point everything should be connected correctly, and it's always good practice now that you think that you have everything connected, just go over it twice, maybe even 3 times. Just make sure everything is wired up correctly. Could also be a good idea to take a photo here right now. Then I'll just add the last standoff and attach everything. The wires tucked inside. So I 3D printed this piece to mount the receiver here in the back, so we'll just go ahead and put this on right here, and then we'll just attach this guy. Now one thing I forgot earlier is that we should have actually attached this capacitor right here with the battery leads, but we'll just do that last, I guess. So now we'll just go ahead and mount the antennas here in the back. We'll use a couple of zip ties for that. Normally you could just do this, like attach it on the like the last part of the frame, like right here. But since I was 3D printing like a mount anyways, I decided to make a bar for it here to make it fit even better. So we're gonna have one of the antennas sticking up like this, like a bit upwards like that. Then we're gonna have the other one sticking out like straight out back. It's probably gonna work pretty well. Then for the MMCX connector, I actually wanted to switch it out because this was one that came with the VTX. But this one is really annoying because it has this angle here, so it's hard to like mount it in a good way. So if you do buy one of these VTXs with a MMCX adapter, which this one is called, then you should definitely get one of those that has 2 screws here, because you can really like bolt it down then, and those are just a lot nicer to work with. We're actually gonna add this capacitor right here. I'm just gonna attach it now. I don't even need to open the frame, to be honest. So let's just cut these legs. Where you see this marking, that's where the ground is, so we want to keep that on that side. Then we'll just go ahead and solder it on like that. Just make sure that it sits tight so it's not flopping around inside. So I made this little adapter here. It holds the GPS, but it also holds the FB antenna. So it is at a slight angle to make everything fit. I hope that the GPS still works like that. If it doesn't, well, then we'll have to make a better mount in the future. So right now, this one is as low as it will go. I hope we don't have a problem here connecting the XT60 with what's left here. We might want to like chop off a bit of the adapter here. So it's time to add the final piece of the puzzle, this connector. So let's hope everything fits right now. Just go ahead and slide this one in. Yeah, well, the XT60 connector could definitely fit better, but it definitely works. Yeah, then we'll just go ahead and solder this in. make sure you get like a nice connection here. You don't want to get a bad connection when it comes to the XT60 connector, because there's really gonna be like a lot of power going through this one wire right here. Yeah, and we're gonna add some heat shrink, of course. Looks like we got a very nice connection there, and then you just make sure that you got the polarity right, because if you get this wrong, well, then you might just blow up your whole quad. So yeah, definitely make sure to get this right. So we're pretty much done with the build, and yeah, there's not much of a point at attaching this top piece actually, because we're gonna wanna plug it into the battery power now, see how it actually performs. But yeah, it does look very good. I do really enjoy how this build turned out. So at this point, we've double checked all the connections, and it's time to check the internal resistance of the battery lead. Now you should always do this if you have a multimeter, of course. And first time you power your quad up, you really want to use like a smoke stopper or one of these lab power supplies. But if you don't have that one, just make sure to double and triple check everything. So we're gonna power up our power supply now and set the current limit, and then we're gonna try to power this guy up. So I got my current limiter set up here, and I'm just gonna make sure to get the polarity correct and power it up. Cool, it's a bit of a spark there. But yeah, it does look very good. Everything seems to be powering up. I can see the GPS lighting up, the receivers lighting up, and yeah, everything seems to be working. And this is also getting warm, so yeah, I guess we have our VTX on as well. And here is where you really see your build coming together very nicely. So it seems I have to actually do some changes to this 3D print right here. I'm gonna fix this 3D model and then redo this whole thing. But we can still go ahead and continue with the build. We're gonna make sure that the GPS works before I do any changes, because I might need to put it straight out also at the same time. We're gonna put on our battery strap as final touch. It's actually powering on. This prop isn't actually attached. You should always be careful the first time powering up. Make sure you don't have any props on. You never know what's gonna happen. So what we'll do right now is we'll take the cap off the camera and we'll see if we can find the FB frequency. So let's use the band scanner. And there we go. We have a connection. So that was it. We have finished building this quad, and in the next episode we'll take a look at the software setup and actually get this thing flying. And anyways, I just want to say a huge thank you to all of you people who subscribe to this channel. We're reaching 1,000 subscribers any day now, and that is just an insane number. Your support and comments and likes and everything is really what keeps this channel going. Anyways, until next time, I'll see you in the next video.